Hi students, I welcome you all. Today we will talk about isotopes and isobars, which are very interesting topics because they show a little bit variation from what we have been studying so far. We have been studying about, that every element has its unique atomic, masses and atomic numbers. So here comes the variation part. Okay, so isotopes are something which have, I'll tell you a trick to remember this also. Okay, so isotopes are something which has, just a second, let me just take the pen. Yeah, which has atoms of same element, okay, with same atomic number but different masses. Okay, for example, hydrogen is there. So the element is same, right? The atomic number is same. Okay, but masses could differ. It can be 2, it can be 3. I'll tell you how. Okay, so due to its varying number in the neutron. So we remember that the mass is calculated, atomic mass is nothing but number of proton plus number. Okay, electron. Oh, sorry. 1 second. Let me just neutron. Okay, so here the number of neutrons could vary, and because of that, you will see slight change in the masses of different element. Not all elements, there are exceptions only that we'll discuss. And isobars are atoms of different elements but can have same mass number. Okay, but different atomic numbers again. Okay, so here the same atomic number is there, but mass is different. Here the mass is same, but the atomic number is different. Now I'll tell you how I actually remembered it. So just a second. Different masses. And here, okay, yeah, let me just skip that trick. Maybe it won't be that useful. I think you can make your own trick. Okay. And if I come up with the trick, I'll tell you in between, okay, in the session. So isotopes, same element, different neutrons. What exactly is happening here? There are 3 examples which usually asked, as it is, they can ask you example. Like they can ask you definition and exactly example, and this will give you good marks, good enough marks. Okay. So hydrogen. Hydrogen, if we talk about, hydrogen can exist in 3 forms. Its mass could be either, let me just change it, the color. Yeah, its mass could either be 1, 2 or in 3. So the water which we use, no, the mass for that water is H1 only. Okay. So the mass is 1 only, and that is what makes water. If we'll use deuterium, and the name of that hydrogen is protium. Okay. For having a hydrogen having mass 2 is deuterium, and the third one is tritium. So if we will make water with this, it will become heavy water. Okay, so this is the example. Then carbon also, here you can see that carbon 12 is there, right? That is used to calculate the mass of different elements, to compare and relatively discuss the mass of different elements. C13 and C14 also exist. Okay, so these are the common ones. And most common is C12, seen everywhere in all organic compounds. Okay, chlorine has also 2 different masses in which it exists. The first is 35, okay, and the second one is 37, right? So these are the isotopes. Okay, so application of these isotopes could be, for example, iodine 131. Actually, it is used to diagnose the thyroid diseases or disorders. Okay, so the thyroid gland naturally absorbs iodine, making radioactive iodine an effective treatment. So if you will be given with the radioactive, this, you will be able to be diagnosed with any kind of thyroid issues if you are facing. Okay, industries use cobalt 60 a lot. Okay, because it emits gamma rays that is used to treat cancer. So all the radiotherapy you might have heard about, they are using this metal or this element, you can say, which is emitting gamma rays and helping in treating the cancer condition. Okay, C14 is used in, carbon dating. Now, what exactly carbon dating is? It is used to determine the age of any kind of organic matter or material is there, fossil and all. So you might have seen, scientists or people telling that this fossil or this organic material is such and such year old, 3,000 years old, 6,000 years old, 60,000 years old, right? So this sort of carbon is used to we will talk about this carbon dating when it comes into your chapter. It is very interesting, okay, later. Now researchers, isotopes also used in certain kind of researches because they are different, so they can be used to identify something. They can be used to label also, like you can label it, label things with using isotopes. Okay, how it's done we will see in the classes which will be containing these topics in depth. Okay, now isobars, if we talk about, so isobars have same mass but it is of different element. What is happening here is, if you can see the argon and calcium, okay, their atomic number is completely different. But if you'll see, they have the same mass. Why they have the same mass? Because isobars have different numbers of proton, but the total number of nucleons, that means proton plus neutrons, would be same for two different elements. For example, argon and for example, calcium. So their proton and neutron number will become same, and that's why their mass number will come out as same. Okay, one more example is there is of carbon 14 and nitrogen 14. So they have again different atomic number, as you can remember, if you can recall the atomic periodic table. So it's hydrogen, helium, lithium, beryllium, boron, carbon, right, on the 6th, and nitrogen on the 7th. So these two elements, even though they have different atomic number, they have a similar mass, that is 14. Okay, right? So this is all about the isotopes and isobars. So here, if you want to differentiate a little bit, you can see the atomic number. Let me just change the color. Yeah, isotopes are same as atomic number. Isobars are different from atomic number, right? Mass number different, mass number, and isobars have same mass. Okay, now element, it is of same element, isotopes. These are from different element, if you can remember the example, right? 40, and this is also 40. Chemical properties, isotopes will be having chemical properties because they are made up of same element, right? So same kind of, almost same kind of properties will be there. But since here the element is completely different, you can say the chemical properties of isobars will be completely different and new. Okay, examples, you can take example of carbon or hydrogen, right? Iodine, any example you can pick. And isobars, here is the example. This is 40, okay? 40. Right? Okay, so now you can answer these questions. So first question is, which of these are isotopes? So if you can remember or recall that whether isotopes are made up of same element, and whether its mass is same or not, then you can answer this question. And if you can't, just go back through this video again and try, answering this. Okay. Now, question 2 is, carbon 14 is used in treatment of thyroid, cancer therapy, or carbon dating. Okay, you can figure out. And lastly, isobars have same atomic number, different mass numbers, or same mass number, different atomic number. So you can, if you can remember all the characteristics of, isotopes and isobars, you will be able to solve it. A bunch of times, one question would be there usually in your paper. So try, and this is an easy topic, which you can, few examples and just definitions would help you solving, getting marks. So just try, solving this. Now, I have already told that these are used in different ways. So this is just a summary, which you can again go back and then try answering those questions. Thank you so much for joining the session. I hope you understood and enjoyed the session, okay? And if you have any doubt, again, feel free to reach out to me through my Urban Pro profile. Once again, thank you. And with this, we are done with the chapter. So we are done with a lot of chapters, and hope to see you in other classes where I'll be taking biology and physics in the same way, or maybe in more, enthusiastic and better way. So I'll keep trying updating and upgrading. Okay, take care. Bye-bye. See you soon.